All right, today we are going to be going over section 5.1, exponent properties and how to solve equations by getting a common base. So let's begin by reviewing real quick the exponent properties you should have learned previously. Also, if you hear my dog or my dishwasher in the background, I do apologize. I live in an apartment, don't have tons of extra space, so all right, so first up, if your exponents have the same base, in this case they're both an x, and you are multiplying those two exponents, you can simply add the powers to combine it together. So our example, 3 to the 1/2 times 3 to the 1/2, that is going to be, they have the same base of 3. We can add those powers together to get 3 to the power of 1. Similarly, if we are dividing exponents with the same base, we can subtract the powers, right? So here we have v to the 1/2 divided by v to the 3/2. Those are the same base, v, so we can subtract the powers. 1/2 minus 3/2 is -1. If you have an exponent being raised to another power, you can multiply those two powers. So here we have n to the 3/2 raised to the power of 1/2. So we can multiply those two powers together and we get n to the power of 3/4. If you have a fraction being raised to a power, you are going to raise both the numerator and the denominator to that same power. So here if we have x to the 1/2 over x to the 1/2 raised to the power of 3/2, then we are going to raise both the numerator, x to the 1/2, to that power, and our denominator to that same power. Now here in this particular example, we now have a exponent being raised to another power, so we can multiply those powers and get x to the 3/4 over x to the 3/4. If we have a negative exponent in the numerator of a fraction, we can simply move it to the denominator of the fraction and the power will become positive. Same thing if we have a negative exponent in the denominator of a fraction, we can simply move that whole exponent to the numerator and it will become positive. So we have an example here, x to the power of -1/2. We move that whole exponent to the denominator and the power becomes positive. This would also work if we had, let's say, x to the -3. This is really a fraction over 1, so this can be turned into 1 over x cubed. If we have 1 over y to the -2, that's the same thing as y to the -2 over 1, or excuse me, y to the +2 over 1, or just y squared. Our last couple of properties, anything raised to the power of 0 is equal to 1. Okay, so x to the power of 0 is equal to 1. That is a typo, that shouldn't be there. The number 100 raised to the power of 0, also equal to 1. If I gave you some crazy monomial, x cubed, y to the 7th, z to the -4, raise all of that to the power of 0, that's still 1. It does not matter what is being raised to the power of 0, anything raised to the power of 0 is equal to 1. This last property deals with converting between rational exponents and radicals. I don't think you actually need to know that for this section, so we're going to skip it. All right, we can use all of those exponent properties we just went over to simplify exponential expressions, right? So number 1, we have division of exponents with the same base, so we can subtract those powers. 14 minus 3, we end up with x to the power of 11. All right. Number 2, we have an exponent raised to a power, so we can multiply those powers, and we get a to the power of 20. Number 3, we don't love negative exponents, so anytime we have a negative exponent, in order to simplify it further, we are going to move it to the other part of the fraction, and we get 1 over k to the 8th. Example 4, if we have x squared times x to the 9th, those are exponents with the same base. They are being multiplied, so we can add those powers, x to the power of 11. Example 5, this one is a little bit trickier because we have 2 separate exponents, one with a base of x, one set with a base of y. But again, they are being divided, so we can subtract those powers. We subtract the powers of the exponents with the same base. So here we have x to the power of 40 minus 11, and y to the power of 46 minus 22. 40 minus 11 is 29, and 46 minus 22 is 24. Example 6, we have a fraction raised to a power, so we are going to raise both the numerator and the denominator to that power. In the numerator, we have an exponent raised to a power, so we multiply those exponents, we get t to the 6th, and in the denominator, it's just a number squared. 4 squared is 4 times 4, which is 16. All right, now we can also use this to solve some equations. If we can get the bases to match across both sides of the equal sign. So here in example 1, we have 2 exponents that are set equal to each other, 4 to the power of x and 2 to the power of 3. Currently, those do not have the same base, but we can make them have the same base because we know that 4 is the same thing as 2 squared. So if we rewrite 4 as 2 squared, that is still being raised to the power of x. Now we can get the same base. 2 squared to the power of x is a exponent raised to a power, so we multiply those 2 powers and we get 2 to the power of 2x is equal to 2 cubed. Now, here an interesting thing happens. When the bases match up, we know the exponents have to equal as well. So we can just drop those bases and set up our equation. 2x equals 3. Solve for x by dividing by 2, and x has to equal 3 halves. Example number 2, same idea. Here we have 9 to the power of 2x equals 27 to the power of x minus 1. Those do not have the same base, but we can make them have the same base because we know that 9 is the same thing as 3 squared, and 27 is the same thing as 3 cubed. So we can rewrite the 9 as 3 squared to the power of 2x, and 27 as 3 cubed to the power of x minus 1. Now, again, we have exponents to a power, multiply those powers. We get 3 to the power of 4x is equal to 3 to the power of 3x minus 3. We can drop those bases because they are the same. Get 4x equals 3x minus 3. Let's get all the x's on one side, and we find that x equals negative 3. Okay, example number 3. Here, we need to rewrite 25 as 5 squared. 5 squared to the power of x equals 5, power of x plus 2. Now, multiply those powers. We can drop those bases, subtract x on both sides, and we find that x equals 2. Okay, some more examples down here. We can rewrite 16 as 4 squared. So this becomes 4 squared to the power of x plus 1 equals 4 to the power of 2x. Multiply those powers, we get 4 to the power of 2x plus 2 equals 4 to the power of 2x. Drop those bases. 2x plus 2 equals 2x. Subtract 2x on both sides. And that leaves us with a problem. Does 2 equal 0? It does not, so we don't actually have a solution here. There is no value of x that will make this equation work. All right, let's check example 5. Whoop. Okay, so here this one gets a little tricky. Fractions are not our favorite thing. So we are going to use one of our properties. 1/2 is the same thing as 1 over 2 to the power of 1. And we can get rid of the fraction by making this a negative exponent. Okay? So now we have 8 to the power of 2x equals 2 to the power of negative 1. We can also rewrite, let's see, 8 as 2 cubed. Sorry, it took me a second to figure out where I was at. Lost my train of thought. So now we can rewrite 8 as 2 to the power of 3 raised to 2x equals 2 to the power of negative 1. Multiply those powers. We get 2 to the power of 6x equals 2 to the power of negative 1. Drop the bases because they are the same. Divide by 6. And we find that x is equal to negative 1/6. Okay. Example 6. Same idea as before. We've already done an... Wait, is this the same example? Not the exact same, no. Okay. But here we need to change both sides. We can rewrite the 9 as 3 squared and the 27 as 3 cubed. So this becomes 3 cubed to the power of x equals 3 squared to the power of x plus 1. Multiply those powers, we get 3 to the power of 3x equals 3 to the power of 2x plus 2. Drop the bases, subtract 2x, x is equal to 2. All right. So we can also use other exponent rules to solve. That's a true statement. I don't know exactly what that means, if I'm being honest, but same sort of idea as before. Okay. Here we have a power raised to a power. So multiply those powers. 4 to the power of negative 2x equals 16. Let's rewrite 16 as 4 squared. So 4 to the power of negative 2x is equal to 4 squared. Drop the bases. Negative 2x equals 2. Divide by negative 2. X is equal to negative 1. Example 8. So here, this is what it meant. Okay, so here we need to get these two exponents on the left side into 1 so that we can do the same process as before. Here we have exponents with the same base that are being multiplied, so we can add those numerators. This becomes 5 to the power of x plus 1 equals 5 cubed. X plus 1 is 5 to the power of 2x plus 1, which is equal to 5 cubed. Drop those bases. 2x plus 1 equals 3. Subtract 1. 2x equals 2. Divide by 2. X equals 1. Example 9 has a typo. There should be an equal sign, but there isn't, so let's make this 3 to the power of 3. I think that'll work out. Anyway, on the left-hand side, we have a division expression with exponents with the same base. So we can subtract those powers. We get 2x minus x minus 1 equals 3 to the power of 3. 2x minus x is just x, and minus a negative 1 becomes plus 1. Now we have the same base, so we can just look at the powers. X plus 1 equals 3. Subtract 1, x has to equal 2. All right. So flipping the page, let's go through this real quick. Solve the following and identify the rule. This is great practice for you guys. I'd recommend pausing the video here, trying this page on your own, and then coming back to check your answers, but you do you. I'm going to assume that you have taken my advice and paused the video. Here are the answers. X squared times x cubed is x to the 5th, because you can add those powers. X to the 6th divided by x cubed is x cubed, because you can subtract those powers. And x cubed to the 5th power is x to the 15th, because you can multiply those. Over here, we need to solve for x. We can recognize that 125 is equal to 5 cubed, and we can rewrite this as 5 to the power of 3x equals 5 cubed to the power of 2x minus 1. Doing that multiplication on the right-hand side, we get 5 to the power of 6x minus 3. We have the same base, so we make this 3x equals 6x minus 3. Subtract 3x on both sides. 0 equals 3x minus 3. Let's add the 3. 3 equals 3x. Divide by 3. And we find that x equals 1. All right. Example 3, we are trying to find the error in this situation. So here we have 2 to the 3x equals 4 to the x minus 1. Okay, we need to get these two sides to have the same base in order to solve this equation. They do that by squaring the left-hand side. If you square one side of the equation, what do you have to do to the other side? Also square it. So this doesn't really work. This is not how you would go about solving this. Instead, we would recognize that 4 is the same thing as 2 squared. So we would rewrite the 4 as 2 squared raised to the power of x minus 1. Now, doing that multiplication on the right-hand side, we have an equation of exponents with the same base, so 3x is going to be equal to 2x minus 2. Subtract the 2x, and we find that x equals negative 2. All right, now, last thing. It has been brought, well, hasn't really been brought to my attention, but I have realized that some of you might be wondering, how do you figure out which base to rewrite and in what way? Like, how did I know to rewrite 125 as 5 cubed? So what you want to do is look at your two bases and then take a look at the larger one first, all right? So in this case, we have 125. We need to break 125 down into its factors like we did when simplifying radicals. So I would say 125, that's divisible by 5, which would leave behind a 25. 25 can be broken down into 5 times 5, so that gives us 1, 2, 3, 5, so that has to be the same as 5 times 5 times 5, or 5 cubed. Right? Now, luckily for this one, that gave us the same thing as, like the same base as the left side of the equation, so we knew that that would work. Let's take a look again at example 6. 27 to the power of x equals 9 to to the power of x minus 1. So if you do the same strategy that I just talked about, we would take a look at 27, say that's divisible by 3, leaves us 9, 3, and 3. So 27 is the same thing as 3 cubed. But that doesn't quite match up with that base of 9. So we would look at 9, recognize that that is the same thing as 3 squared, and those are going to have the same base. So we can rewrite our equation using both of those. 3 cubed and 3 squared, and go from there. Okay, so what you want to do is take a look at the larger base, whichever base is larger, break that down, okay, into its factors until you figure out what it can be rewritten as something squared, something cubed, something to the fourth, whatever. If that ends up being the same base as the other side of your equation, fantastic, you're in great shape. If, however, it doesn't match up, then take a look at the other base, break that down to its simpler factors, and hopefully at that point they will match up.